Huygens says light is a wave and gives us a way to figure out how the wavefronts evolve. A wavefront can be thought of as a set of particles which are oscillating in sync with each other. So if this was, say, for example, light, then according to Huygens, every point on this wavefront acts as a source for secondary waves, and the envelope of these secondary waves, a common tangent to them, represents a new wavefront. But can we use this to prove laws of refraction? Let's say we have light moving from one medium to another, say air to water, and here is our incident wavefront. The moment it hits the surface of the water, every point on the water behaves as a Huygens source and starts producing secondary waves in the water. We are of course neglecting the reflected waves over here. And notice the waves are slower in water compared to that of air. And now when we draw a common tangent to these secondary waves, we get the refracted wavefront. And indeed we see, because the waves are traveling slower, the refracted wavefront is bent towards the normal. So now let's see how to draw this step by step on a piece of paper and see if we can prove Snell's law. So here's our air and water. So let me draw a couple of incident rays of light. So I'm gonna put my ruler over here, and here's my first incident ray. And I'm gonna draw two incident rays of light. And here's my second ray. I'm gonna draw them parallel to each other. And so basically I'm imagining that the source is far away. You might recall that when the source is far away, the rays of light become parallel to each other. The source is at infinity, you can say. And when that happens, what happens to our wavefront? Remember, when the source is at infinity, the wavefronts are plane wavefronts. And when I'm drawing over here, they're gonna be straight lines. And how do I draw my wavefront over here? Well, wavefronts are always perpendicular to the direction of the rays. And so I can now bring in my set square and draw my incident wavefront. So let me use dotted lines or dashed lines so that we can differentiate between rays and wavefronts. So here's my incident wavefront. All right. So let me write that as well. This is incident wavefront.